Next, it's a sad fact that most of the plastic we put in the recycling bin still ends up buried at the tip. What if we could stop it cluttering up our landfills and reduce greenhouse gas emissions as well? That's what one visionary scientist asked herself, and she thinks she's found an answer, turning plastic into steel. Veena Sahajwalla, Professor of Materials Science at the University of New South Wales, can't stand waste.
Being a person growing up in a place like India where, waste, we didn't think of anything as waste. We wanted to reuse and recycle just about everything.
She's particularly bothered by plastic. We devour over 1 million tonnes each year in Australia. Some of that's recycled, but most of it's buried in landfill. And Veena was convinced that this plastic was meeting its end prematurely.
Being a material scientist, waste is still a material, and if we can actually convert this waste into a resource, wouldn't that be nice?
Which is how she came up with an ingenious idea, using waste plastic to make, of all things, steel. We produce millions of tonnes of iron and steel every year in furnaces that burn at temperatures of over 1600 degrees Celsius. It seems like the last place you'd expect to find a use for plastic waste. But plastic has something in it that's vital for making iron and steel. Something that makes it strong, so we can build everything from steel cans to huge bridges. Carbon.
This is some of the material that you're...
Yeah, this is what we call our nut coat tile.
Yeah.
Right now, most mills get their carbon from adding coal. You need roughly half a tonne of coal to make 1 tonne of steel. But plastic is also rich in carbon, and Veena wondered if she could use plastic to replace some of the coal, and in doing so turn a waste material into a resource.
So if we're looking at waste plastics, which is another form of carbon, if we can demonstrate that that can be used successfully, and that's got a huge impact, yeah.
Inspired by some early Japanese research, Veena set to work in her lab to find out exactly how plastic would fare inside these fiery furnaces. Her team grinds up plastic and combines it with varying amounts of coal.
Karina, what we're going to do is we're actually going to be feeding in our plastic sample in there. And the idea is we want to be able to inject it into this furnace here.
Yep. Have a look at what comes out the other end.
That's right. So effectively, it's like having the snapshot of what the sample would actually be when it enters into the real furnace.
And so far, so good. The coal and plastic mix is proving to be a great source of carbon in the furnace. In theory, it shouldn't produce any noxious gases at these extremely high temperatures, and what's more, could result in less carbon dioxide than coal alone, and that means less greenhouse gas. But the lab work is just the beginning. Veena's next step is to try and convince industry. She guessed the steel mills would be sympathetic because they already recycle, like this plant in Sydney, which makes its steel totally from scrap metal. But the steel mill's main concern is that using plastic shouldn't upset production.
Any modifications we do are based on sound business sense, so if there's commercial advantage to us and also environmental advantage, then yes, we'd do it.
It has the potential to reduce the plastic mountain by 200,000 tonnes each year. Now Veena needs to find someone who can process waste plastic into a form the steel industry can use. But what are her chances?
I'm a very optimistic type of person. I believe that all of these industries, I'm sure, would like to do something good for the environment. And if it's the idea of using waste resources, which minimizes how much waste we send to landfill, I think that we'll be able to work with companies to do this.